Well, hi, good morning, and thanks so much for joining me here in my shop on the 13th of May. And what I'm going to be working on the radio today are these push buttons. These very cool looking 6 push buttons here. So I've already got an impression of how they work and the like, but we're going to take a close look at them. So one of these has already failed because of a piece of material is broken, as we'll see in a minute. So I really have a number of questions about these guys. First of all, how do they work exactly, which I think I know already. What happened to the one that broke? Why did it break? Can the one that broke be repaired somehow? I'm kind of doubtful of that. What condition are the other ones in? Is there something about the other push button mechanisms that I can look at and go, ooh, this one's ready to fail? How much more life is left in these buttons? How many more times can I push them? One's broken already, so you'd think there must be some limitation there. Is it worth it for me to bother tuning these up? Often these buttons on radios, they don't tune 100% on the money. They tune very, very close. It's very hard to get these exactly right. So what's the use of that? You know, it's not like I'm going to be playing this radio every day. Chances are, once I'm done with it, it's going to sit on the shelf and not be played for a very long time. That's the truth of it. So it's kind of a one-shot deal in terms of if I'm going to tune these guys up and not do it and be done with it. So that's probably okay to do. So, first step. How do these work? What are they doing? So in some push-button radios, when you push the button, the big tuning capacitor is rotated mechanically to a certain position which the button is in control of, and so then if you grab the tuning knob you could just tune it away if you wanted. The other push button radios have a separate set of coils in them, and you are actually, when you push the button, you're actually selecting a different set of coils. So it doesn't matter where the pointer is, and you can turn the pointer all you like while the buttons are operating. The VFO, the variable frequency oscillator, is not being utilized in the radio. This one's mechanical, and I know that because if we just push one here, wait a minute, didn't I lock this one? No. Okay, so this is not a good idea, but I'm going to do it anyway. See, so you saw the pointer move, you saw the knob turn, and that's working in this radio because this is so loose, so easy to turn. And that's probably because my predecessor, whoever it was, probably took some care to lubricate all this stuff. Okay, so this is a very unusual set of buttons. I've never seen one that works like these, so let's take a look at them. I can spin this around enough. So one of them should be standing out right away, and I have this one with the broken strip on it. And I'm going to get a close-up camera in on this in a moment. So you can see the tuning capacitor here, and if I turn it, you can kind of see what's happening. This is a pretty wide shaft here. Yeah, I'm going to need to put the, I think I'm going to need, let me if I can get this camera to sit right over top of this stuff. Let's try this. So this is set to come up really close. So let's use that right on the first, this one. That's broken here. Well, first thing I see is it's being smashed right there. What is going on right in here? So the rivet appears to be off center here. Like it's pushed. Let me get something to point with. The rivet appears to be off center. Is it? That other piece appears to be bent out of place. This piece right here appears to be bent out of place. Because if we look at the next one over, see they're up tight? This is it right here, it's up tight. Two pieces of metal pressed tight. Tight, 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 bent, tight, tight. Do I have to say tight every time I see one? These are tight. These are all tight. So one of them is in a weird state with a piece of metal that's not in the correct position, and that's the one that's broken. Now you can almost see the failure method here. Now, what happened to this piece of metal? Wait a minute now, you know what? It's not this one. It's this one. This is the one that's bent. Oh, look at that. These are all that loose. It's like it's come loose in its housing, sort of. So who's bent here? Well, the whole thing is moving. I'm going to change the focus on this camera and steady it up. Just bear with me 1 second here while I do that, because it's up just a little bit too close. So I have to call up the excuse me, camera dialog box and change that. There we go. Okay, I think that'll be more comfortable there. Ooh, look at that. Cracked wire. So this cracked wire we're looking at goes up to the magic eye, and it's very common for these wires to be cracked. Often in some radios, in one radio model in particular, these wires come up through a hole like that, and then they go right against the rectifier. This is not the rectifier tube in this radio, but they go right up against the rectifier, and the wires cook. They become totally stiff, and if you bend them at all, that's what you get. And this looks almost like the same effect here, because they're not cracked elsewhere, just down here. So maybe this was wound in behind the tube or something. I don't know. We don't know the whole history of this chunk of wire, but is that a real problem there? Not as it stands. It's fine the way it is in an old radio like this. Okay, so what I'm doing now is I'm grabbing the front knobs and wiggling them. See, this is pretty trapped, and this one's pretty trapped. For this one's really come loose. Loose from what exactly? Let's talk about how these operate. So you see there's a rivet here, and then the band going down and under, and the band coming over the top. It comes over the top, and it's riveted. I got to tune this to produce the rivet. There, you can see the top rivet there. So they're all in a perfectly straight line. They're all riveted the very same. Probably the same over here. Yep. And then you can just imagine that underneath looks exactly the same. The material comes down, loops under, and comes up and meets up with a rivet. When you operate it and you push the button, you stretch that out. Let's see. You stretch it out. And this is banging into a wire here. You stretch it out. Now there's a locking mechanism. I'm going to try to, this is the part I haven't quite figured out yet. So let's figure this out. So the locking mechanism works by rotating the knob until it tightens up. So that's locked, that's unlocked. So the idea would be you tune the radio where you want it. Then, with it in the unlocked state, you push this button in. You push the button in firmly all the way. You then lock it. Okay, I'm locking it. think I saw what happened. I think I saw what happened there. No, I did not. Okay, so now it's locked. So now what I'll do is we'll try it out. Okay, so we'll tune the radio over here and we'll push the button. There it goes. And then go here again. Tune the radio. Now push the button. So in this case, the top band is going taunt first. And then it's going to pull it. Always pulls it so the rivets in the same. That doesn't make sense. Let's try another one over here. Okay, so I'm going to set this one to a different spot. I'm going to tune way over to the left here. Okay, push it out, lock it in. Okay, it's locked. Retune the radio here. And we'll push the button. Which one did I just do? Not that one, that's the broken one. There she goes, all the way across. Okay, I'm trying that. This time we'll look right down at the mechanism. Okay, I think I see it. I think I see what's going on. Okay, I think I see it. So what's happening back here in the back part of these bands is when you tighten them up, I think I got it. Let's see if this is true. It's easy to look at this one. This piece, when you tighten it up, is driven forward and binds the rotating shaft that's down in here. See, it's not a continuous shaft through all these. Each one has its own little rotating shaft in here. This will rotate into the right place when it's unlocked and you depress the button. Let's watch that action. So I've got this one set to the left. Let's set this one over to the right. So I'm tuning the pointer all the way to the right here. Almost all the way to the right. Okay, unlocking this one. Now I'm going to push the button in. Okay, and the idea is it's going to rotate this, the final thing, it will rotate that piece there. Let's see, yeah, it's rotating a little bit. Now I'm going to tighten the screw and I think you'll see the inner slide come forward and bind. Wow, I didn't see any movement at all. Sure feels like that's happening. So maybe it's binding it and we can't see how it's doing it. So we'll assume that rotating spool at the end there is now unable to rotate. Okay, so I'll dial the radio. Yeah, see it's not rotating back there. Now I'll push this. Push, man. There it goes. So in a sense, so the band is locked onto this rotating part here by a rivet. Where's that? Oh, I gotta unlock it. Unlock it. Now if I push it in, I think so now the round part at the end here is going to rotate freely. Can't quite see the locking mechanism. So when I'm rotating this knob, you can't see anything rotating in here. So the rotation is occurring inside that tube with the spring around it. I'm sure we're driving this piece forward, and then it forks the rotating thing. Maybe if I loosen this enough, we'll see that. Oh! Did I ever loosen it? I loosened it a lot. Well, that gives an idea how long this thing is. So if I put this like this and I look down, that's kind of awkward. Let me stick it through the hole here to the side. There. So that's giving an idea how long this is. It's just long enough to push that internal C bracket. Let me stick it back in the hole here. obviously this is a fractional thing, you know, it just needs to move a fraction to bind at the other end. I can't move it. But well, yeah, that must have room to move forward. Okay, the screw, the knob thing is as loose as can be. Oh, there's a little bit of play there. The whole thing is moving though, so I don't know what to make of that. So I still think this internal part is pushed forward. There's down. It's a 4-finger fork here, applying pressure and just locking the ring up here. I'm pretty sure that's how this is working. Okay, now going back, make sure they're all loose here. I want them all loose. Okay, not falling out though. A couple that are ready to fall out here. Just fixing them. Okay, let's go back to the broken one. So if this bracket bent here, braiding the cloth, cutting it. Look, it's actually tearing it away from the rivet. Let's look at the end, the broken end of this. Maybe we can figure out what happened to it. Where did it break anyway? It broke right at the rivet, I'm sure. So it's torn straight across. You think it'd have a little bit of rivet shape to it. Well, it almost looks like it was cut with a pair of scissors. Is there any other damage on it anywhere that we can see? There is, right there. But that's not where it broke. There's no way I'm going to fix this. There's no way this one is ever going to work again, and whether it was caused by the bending of these plates here, or, which I'm pretty sure that's what it was. I want to take a guess that this has been like this since day one, since it came out of the factory. Doesn't look that bad when you kind of move it around a bit. But so now, next question: what about the other ones? Are the other ones on the verge of failure? So there's definitely a failure mode going on in this one, and it doesn't appear to be happening in the others. Let's take a look at them here. I'm going to rotate this up so we can look at the rivet. Well, what we can see looks good. Looks okay. Okay, next one. You know, I watched that program Mayday on TV about airplane crashes, and I'm kind of doing the same thing here with the radio. And I actually do have accident training background. A system called root cause analysis. What you do there is you look at an accident, especially one that involved a person getting hurt, and you try to figure out what the root causes were. But you're not interested in the causes that, you know, like, let's call them acts of God or stuff like that. In this method of accident investigation, you pay attention to what it is you manage as a company, organization, or person that you can change that will influence the accident. This one looks different. This one looks different than the others. This one looks it looks like what they did was they put two pieces under that rivet, whereas this looks like a continuous piece. Oh no, you know what, on the top, it's actually two pieces. It must be the same for all of them. I just didn't notice the first time around. Yeah, it's two pieces. So there's a top piece, a bottom piece. They overlap through that rivet. But the rivet goes through them there. So the impression I get is these have lots of miles left in them. What happened to the one that failed is nothing to do with these other ones. I shouldn't be afraid at all about operating them. Okay. I think that's the bottom line there. No need for fear. No here. So, how accurate are these guys? Even without turning the radio on, we can get a feel for that. We'll set one up very precisely and see what it looks like on the dial. So, let's set them up for 90. I'm looking at the TV screen to line it up. You know, there's a parallax problem with all these radios, right? So right there. Don't rotate the radio. Now we'll set this button loose. Watch the pointer now, see if it travels. So we're trying to set that roller at the back. Okay, I pushed it in all the way. Assumably the roller is set. Do I tighten it up while it's set like that? I think I can let go of it. Maybe not. Okay, I'll push it in. It should do nothing to the pointer. Okay, now test flight. Here we go. Wow, it looks really good, doesn't it? But certainly on shortwave, a tiny little fractional movement can make all the difference in the world. But in AM, not so much. The way they've done this, since it drives the tuning capacitor, it doesn't matter which band you are on. You could choose these to be all AM or all shortwave or whatever you like, except for this one. This one. Let's turn the radio on. I have the feeling I won't be doing anything other than just setting some of these buttons up today. Okay, switch on the radio. So put on the power. Let me just quickly check. We have no antenna hooked up. I think, pretty sure my antenna is switched not into this room. I have to run and deal with that. Maybe while the radio's warming up, I'll run down. Here we go. Okay, I'm going to run and switch. If it catches fire, you let me know. Okay, now full power. I don't like that hum. So which band are we on? We're on the AM band now. That's better.
Greater Toronto. A message of thanks from Global News Radio 640 Toronto. In these difficult times, a reminder that Kotak Law is available to meet by telephone, video, or email. So if your disability claim has been denied, contact Kotak Law today. Visit kotaklaw.com. That's K-O-T-A-K law.com. While you're home, why not lose weight? Call Harvey Booker Weight Loss for Men. Open online and now 40% off. 416-222-9887. If you could do it alone, you would have done it already.
I want to get this radio tuned exactly. That's what I'm doing. Doing a bad job of it.
Alright, well, we're good to have you along on this Wednesday. Today at 1 o'clock, Doug Ford and the Education Minister, Stephen Lecce, will be making an announcement.
ABC voltage.
Later on,
Tuning.
and the feds will be releasing funding for small businesses that don't seem to qualify for rent relief or the wage subsidy. These are people that are falling through the cracks and have been asking
So I've
for
set
help
this
over
meter
and over and over.
right up at the top here, at the top of the peak, very exactly. So if the button doesn't return it exactly, this won't return exactly. Now we'll also hear it too. So we'll pick, we'll pick this button. This is the lowest station I would ever tune. It's loose. I'll try setting the wheel here. Oh, radio retuned a bit, didn't it? Okay, setting it again. Yeah. Oh. Oh. Yeah, I push on this and bending things. And okay, let's lock it. Ooh, sounds great. Now we'll check the meter by tuning to see if we can get it to go up higher. I don't think so. Very nicely done. So I'm going to do AM and 2 shortwave. So the next AM one I would set on here would be 640. Terrible. Is there a radio station there? There is, actually. Big pile of noise right on top. Okay, well, for what it's worth. Loose, set, lock, test. Comes back right to the right spot. Okay, I'm gonna put it. The French station. Quiet. Oh, because I turned the tone control. Actually, I hadn't had the volume up at all the whole time. What happened to my French station? 860. I probably have the wrong antenna switched on. That's probably what's happening here. Okay. I think I hear the station there. We'll accept that. Loose. Set. Oh, so you could see the pointer move that time. Back. Loose. Set. So if the roller that you're trying to set with the rivet in it, if it's a little sticky, then maybe it's going to pull. Pull on the big shaft. Okay, lock it. So it missed because it was sitting more like that. But you know, partially these push buttons just get you close, and then you can tune the rest. Let's go on shortwave, see if we can find that big powerful station right around 9.3. Okay, shortwave. It's quite a ways out of band here. Let me check the frequency that we're listening to. The Overcomer Ministry. Brother Stair.
Brother Stair. S-T-A-I-R. At Overcomer Ministry.
So we think we're around 8,500. I think it's 9330. I'm not sure. Let's find out. So we're going to beat the signal coming out of the signal generator against the one we're receiving, hopefully. So the radio is actually receiving 9.4 and we're tuned to 8.4. Yikes! Yikes! What happened? I thought I'd sorted this out yesterday, but maybe I blew it. What's happening at 15? Is 15 at 15? It's not coming through, so we're gonna have to make it better. I just did a put the insulation, click right on the antenna here. Now my signal generator is now connected to my outdoor antennas, which means that people in the neighborhood can listen to me if they want. Okay, down on this. Now, what frequency is the radio really tuned to? 16.4. 15.5. Definitely not 15. I blew it totally. Bad job done on the alignment on the shortwave. I really kind of had to. Radio Marty. It's out of band. That pop you just heard was my hand brushing up against the meter lead here, and a static charge and just disappearing into it. In case you're wondering. That's a lot of ham radio guys doing CW. Wow. Wow. That's a very low frequency to be. So this is probably up here. My gosh, listen to it go. How's your Morse code? There's too many at once. So this radio, because the band is not spread, can't separate these signals. You're not going to be able to do it. You have to do it with your brain. That's incredible. Now, usually that indicates a contest is going on. Or is this the result of all kinds of people being in their homes? So every ham radio operator out there is on his ham radio now. That's probably true. So no, that's a ham radio guy talking, and it's not in the right spot. So yeah, I blew the alignment here on this radio, no doubt about it. So that's something that has to be fixed up. Well, I got time. Why don't we fix it up? How did I get it so wrong? I was getting confused between the image and the real McCoy, and thought I sorted it out, but obviously I didn't. So, yeah, I'm going to stop for a little bit and just ponder this, get my head clear. I wasn't expecting this. Okay, glad I found it though. Okay, so at 15 megacycles, the fundamental frequency will be obtained with the less capacity setting on the trimmer capacitor. That's the instructions. 15 megahertz. The Wow, I missed it terribly. Cover your ears. No. Something wandering around here? No. So where is 15 showing up? Let's do that. Let's do that. Let's take that approach. So there's 15. Where is it showing up on the radio? Way down here. You get strange, these are oscillations. Originally I was suggesting this was the capacitor rubbing at that point, but it's kind of weird for a capacitor to come into contact and then break out of it again. Usually the capacitor is rubbing. You know, once it gets into contact, it doesn't come free again. Usually. That's a weird oscillation of some sort. That's my signal generator. Let's turn it down a little bit. So why don't I just push this up to 15? Why not? Okay, I'm just going to peek at the instructions here to get the right adjuster. Just 1 second here. So we want to do the high frequency oscillator C4 most inboard one here. Get in there. Very sensitive. Now we want to turn this until it says 15. Where'd it go? First I gotta figure out which way to turn it. Okay. Now, so what's happening, I think I've moved it out of the range of the RF tuning on the front end, and it's just fading out so we can't hear it. Let me boost it up. Really blast it in here. I call this hopscotching. So the capacitor is... What happened? I was just going to say the capacitor is as tight as it'll go, and then gunk. It stopped. Okay, somehow something is there. Now it says it's supposed to be the lesser capacitance, but I've just cranked that trimmer right down, so we're at maximum capacitance. What am I supposed to do about that? Look for another spot on here. Yikes, there's something more wrong with this radio. This is a whopper signal coming in on the antenna. Just in case there's another shortwave listener in my neighborhood. Let me take it off the antenna. My outdoor antenna. That boosted the radio signal. What to think here? 15,000. Just moving the pickup coil. Okay, now if I tune the radio a bit, we should see something move. Just one thing, please. Just one thing move, not all that stuff. One of those is the local oscillator. Now, usually it's really quite powerful compared to all the other nonsense that's in here. Hey, let's do it this way. If we're at 15, the local oscillator should be at 15,455. That's actually right up in here. I don't see anything up in there. But if we've then done it on the wrong local oscillator, the local oscillator is going to be roughly a megahertz high or low. I have to think hard to figure out which one. So if it's high, we can go up there. There's a local oscillator up here somewhere. Now there's a chance my pickup coil's not picking it up. So it's not up around here. You hear me tuning back and forth. Then we'll go looking way down here. There's something right here. Okay, tune the radio. Now I'm going to tune the radio down. In frequency, the local oscillator should go down. Look, it's going up. It's just craziness on my SDR here. It's not going to help us. I need a stronger, more exact fishing out of the local oscillator. Now, local oscillator is stuck into the mixer tube. Let me just to let you know what I'm doing here with the radio. This is my pickup coil, just the clip lead. It's not even a coil. Trying to do here is fish around. So this is the mixer tube. Put this right around the mixer tube, kind of like that. Ow. Jeez, that's really hot tube here. Wow, burner tube. Now what did we get on the SDR? Just go back to that. Oh good, there's a strong signal right here. Now tuning down, that goes up. Now, is that the local oscillator right there? Down around 13 now. Never mind all the sounds. So if we set that to 1455, the radio will be tuned to 15,000. 15,455. Have I been in here too long again? 15,455. Ooh, let's bring that up. I don't want to lose track of it. Where did it go? Okay, there it is. Up around the end. Okay, so we're assuming that red line on the left there that's moving is a local oscillator. Interesting. That's definitely the local oscillator. What's happened here is I've reached the top of the band. I can't tune up any higher. It's an interesting chance to watch what happens to the local oscillator. As I'm just going to tune the radio up to the end of its run very smoothly. When I get right to the end, this line will go all wiggly, but that's not me. I'll be as smooth as I can, just tuning to the very end. Let's see. I'm getting close to the end now. I'm pretty sure I've reached the end. So you see how it actually doubled back? And that's a problem with all these capacitors. Potentially with all these capacitors right at the end of their run, they don't behave properly. So you want to see on the dial what that looks like, because let's look on the dial. Okay, let's try this. Now, the local oscillator is over here. This is the local oscillator. See a little bit of a red line down here. That's the local oscillator. Now, the radio tuned to 16. See the local oscillator there. 16 megahertz, and the local oscillator, according to this, is way, way, way low. Wow, way, way, way low. So I'm going to turn that oscillator adjustment and see if it moves the local oscillator up. Because I can only turn this trimmer in one direction now. That's to loosen it. Okay. Let's see. Oh my gosh, so that's me pushing on the capacitor a little bit. Oh, where'd it go? It just flew to the right. Let me just bring it back a bit. Oh my gosh, it just shot like a bullet. So at 16, it should be 1645. That's off the band. Let's put this on 15. Isn't that spooky? It's working right on 15. And I'm giving it a 15 signal. Somehow, what? I just happen to hit the mark here, just by luck. So, let's look at the local oscillator frequency here. I'll check it with the SDR by just tuning the SDR to the local oscillator here. It's 465. We want it to be 455. But the fact is that this isn't necessarily tuned dead on 15. I mean, look at it. How can you ever get this exactly right? So we're definitely in the ballpark here. Now, have I got this correct? So 15 being transmitted to the radio, showing up at 15 on the dial. How can I have this wrong at this point? Because I'm looking at the image. If I'm looking at the image, then there's another signal in here, 910 megahertz away, either below or above. Don't be up here. And that's the end of the run. Hey, how come this is stopping here? I thought it was supposed to stop up here. What's happened? Oh my god, the pointer's been knocked out. Ah! Yeah. It's knocked out the same amount as it was off. When did that happen? How come the AM band seemed okay? Oh no. Oh, now the string is bunging up down here on the knob. It's all falling apart. It's coming apart at the seams here. Yeah. Okay, you know, face up to it, Jim. A lot of things have gone wrong here. The pointer. Oh my gosh. So what happened on the AM side? No antenna. Put the antenna on. How the heck did this happen? Now that, I think that's 590. Maybe that's 640. Didn't I check this? Are they talking about sports?
Video chat platforms during these times, and they just start using telephones. And
640. So we're listening to 640, no question. Wow, so what happened there was this pointer got knocked off, and I thought I was checking two stations here, improving its position, and in fact, the two stations are shifted over, and I'm actually wrong, but proving myself right at the same time. Hey! That's the human condition. So this should really be 640. And then I got... When did the pointer get moved? How much you want to bet at some point... Oh, I turned the whole thing. Well, let's do this right. Let's do this right. We'll dial in the 640 here. Okay, 640. Oh, I've got my phone in my pocket. Everything's wrong today. So, I'm sorry if my phone has been causing some video interference here. So, no. Just think, man. This is a 640 signal. Does it come to the end dots? No. It's past. It's good here now. How did this move? So I'm guessing my hand must have been on top of it at some point. I was holding it and I tuned. Let's see what happens if I do that. You know what? Can't even feel it in the control. Can't even feel that the string is being pulled through that. So that's got to be what happened. I probably have my arm on it or something. Now, the question is any of this aligned correctly? The ABC meter's really enjoying this. It's a pretty hefty signal I'm feeding into the radio here. Oh man, do I do the whole realignment again? You know what? I first time through. You've got to write it off to this kind of stuff. So I only did one time through. I've set these buttons. They're all set wrong now. That's right. I'm a winner of something. 640. Okay. So what? So pointer's correct. It's correct as I want it to be. 640 is at 640. What am I worried about? What am I worried about? $640. 590 is very hard to hear. 680. It's there. And then the French station. That's 740 there. Now the radio went quiet. It's 860. Okay. Back to the shortwave button. Careful, you do not disturb the pointer. Now we go all the way back to everything I was doing. Back to the 15. There's those weird noises. right on the edge of 15. 15 megahertz. Not hooked up. We're on the outside antenna. Let's get off that. As close as I can get it. $14.5 and $13.5. So that's the two of them. I'm going to move them up. Oh, we should be able to use the SDR now. SDR, Mr. SDR. I'm going to move that local oscillator from where it is, 14,750. Oh, wait a minute. Am I seeing this? No. So the local oscillator, you can see, I can kind of point at it right here on the SDR. I want that to be 455 above 15,000, 15 million. And that would put it, where the red line is. The red line there. So the red line over here is set where I need this to be. You may be fooled into thinking I'm explaining all this to you. I'm not. I'm explaining it to me. The problem is I don't listen to myself close enough. So we want to move the oscillator. The oscillator is most inboard trimmer. Now we can watch. This is where it gets easy with the SDR, because we can watch it. We want it to keep going. Up, no, come back, right around that red line. It's pretty jumpy. Doesn't want to go right. Oh, that's pretty close. Okay. Again, that's because I'm using this flexible. Even though it's pretty big and stiff, it's still got enough flex on it. The stiff screw is hard to adjust. So did we do it? Do we now have 15 at 15? Okay, so we're tuned to 15. Signal generator is hooked up. Let's put the signal generator on 15. Here we go. Son of a gun, why did I go the wrong way? How's that possible? What am I doing wrong here? Local oscillator, what I believe is a local oscillator, is around 15,500. And that should mean the radio's tuned around 15. So we should be able to hear 15 when it's fed in. Am I feeding it in? I certainly am. I'm feeding it in. Boldly fed in strong signal. Well, assuming some other alignment issue now is quieted in the radio, so part of it is working right and part of it's working wrong and nothing's coming out, I'm going to pound it. That's pounding it with a whopper of a signal. What, did I turn it right down? No. Did I not hear a thing? Yeah, way down there. Something's going incredibly wrong. So it must be the case that what I think is the local oscillator on the SDR is not. So if we turn this down a bit, turn this down a bit. I don't think I've ever had so much trouble with a radio. The radio right now is happy to tune in 13.7. That means there has to be a local oscillator frequency either above or below by 455. We look on the SDR, we see something pretty strong, still up close to 15,500. This doesn't make any sense at all. It's too far away. Things are too far apart. If the local oscillator is way off, it should show up. Maybe that's it coming in now on the SDR. That's a stronger signal. That's at 14,750. So let me drive that signal upwards, because this trimmer is very powerful. Yeah, things really move when you turn this. Okay, I'm in. I'm gonna watch that guy go up. Wow, I just like that's like 2 degrees of screw turn, and it jumped all the way almost to where it should be. Oh, okay, back a bit. This is a monster to align. Oh, a little more. Oh, it's like I can feel there. Oh, that's good. Okay, that's close. Now, oh, it's not on 15. Shush up. Now, so I will have moved the local oscillator down. We need to bring it up again from wherever it is. Looks like it's just above 15. Okay, going up. Oh, that one went down. Okay, so that can't be it. How about this one coming up? There's 2 of them coming up. What's going on here? And there's some kind of funny thing going on the SDR. It does a lot of weird stuff, doesn't it? So here it comes. Is this the local oscillator? We went a little bit past with it. So this should be tuning just above, just around 15, just above. How do you like that? I got it. Now we gotta ask the question, am I on the image? Is this an image effect, or is this the real McCoy? We look up and down, 900 kilohertz for another. There's nothing there. So if that's a capacitor thing, you'll hear it on the other band. There's nothing. Some more weirdness in this radio. Can you get 15? Yes. Now we're going to do the RF to match this. Let me tune it this way a little bit better. Okay. Now the RF trimmer is what? What is the RF trimmer? Or should I try moving that for the oscillator just a touch? It's 50 kilohertz high. Let me go at it with a metal screwdriver here. 50 kilohertz high. Oop, I just accidentally moved it. Where'd it go? Oh my gosh, it's unbelievably sensitive. But I can do it with this metal screwdriver a lot better. Onto the red line. Okay, you know what, I'm not going to get any closer than that. lost my train of thought here. So we're hearing, oh yeah, it's going to do the RF alignment here. RF, let me just look in the book quickly on my own. The RF is done with RF, just hang on. Second in from the edge. Okay. Let's try this one. Second in from the edge. And what are we watching? Should try to watch this meter over here. So strange how it just disappears there. Kind of, it pulled in for some reason. So that's RF and the oscillator aligned here. Is this radio really right? I don't know what that is yet. Let's go back to the antenna. Whenever you're operating a communications radio, shortwave radio, and you're actively tuning around and listening, you need one hand on the volume control the whole time. A lot of radios are made, they thought of this, and they're made so that the controls are kind of separate, and you can have one hand on the volume while you tune, even though there is an automatic volume control. Look at what can we get? We're on an antenna. Sounds deathly quiet. Oh no. All kinds of stuff in here. There's a band indicator right there. And you see the pointers right in the band indicator. Earlier I was saying, oh, this is out of band, out of band. They're not anymore. Let's see if I can stop on one.
Organizaron toda esa matanza contra los judíos. Pero Hitler siguió, invadió Checoslovaquia. Churchill, viendo todo lo que estaba pasando, pidió poner en un 28. La noche de los cristales rotos fue en noviembre, fíjense ustedes. Hitler le pidió a Chamberlain que pusiera la industria de Inglaterra en pie.
This radio, you tune right past stuff without even knowing it's there. It's so fast. There is nothing there. Okay, we'll go down to the next band. There's WWV. Right on 10. Hey, pat on the back. Pat on the back. A real powerful station, just around 9.3, right about here. Wow. That's a beast. Let's turn him down. Where'd he go?
Is much more subtle. Sudden, people are more likely to be deluded into believing error because 90% truth mixed with error is still error, even if it looks like and sounds like truth. Yeah, makes sense. It's how he gets good people to do bad things, though, isn't it? Right. Steven Weinberg is a Nobel laureate. He said something that is very insightful. He said, without religion, you would have good people doing good things and evil people doing evil things. But for good people to do evil things, that takes religion.
No such thing as good people and evil people. Come on. People aren't evil, they're good. And here's something you should think about as I turn this off. No matter what people do, inside they feel fully justified in every action they do. You never do things you do not feel justified for, even if it's a screwball justification in your head. So when you approach somebody who's doing something wrong, they don't think they're doing anything wrong. I don't do anything wrong. Do you do wrong things all day? Yeah, I like to argue with people on the shortwave because you know what? They can't argue back. And even on my videos, you can't argue back. It's fantastic. I'm in a beautiful shell here. Okay, I'm a little happy because I solved a unknown alignment problem I created yesterday. I'm very happy with the radio's operation at this point. Satisfied with the buttons. Don't want to do any more to it essentially except put it back together and give it one good tuning, one good listening test. Maybe this evening. Maybe. Okay, thanks a lot for watching, and you'll see this radio one more time when it's back in its cab.